Some extremely strong downdrafts that occur in the rear flank. These downdrafts are interesting because you see the rain, this is rain, and you might think the rain is causing the air to, dragging it, all these things we learn about downdrafts. What I think is happening is there's some dynamic forces that are pushing the air down and basically dragging the air down basically along for the ride. It's almost like the air is being pushed to the ground, which is bizarre. Again, the blue here is the cold pool, the red air is warm air, and this air is the atmospheric air. So we have air in the rear flank where you typically expect it to be cooler, actually warmer from compression as the air sinks. Meanwhile, this tornado is getting pretty crazy. It gets even crazier. You'll see in a few minutes, there's a second tornado that will form right about here. That's an anticyclonic tornado, and I will call it a capital T tornado. It's definitely not just an anticyclonic vortex. And you're going to see it form. Just keep your eyes right about here. You can already see the anticyclonic type of motion, but there we go. And what the heck? I saw this, I'm like, you gotta be kidding me. And then I watched it a little more, and I'm like, seriously? You're gonna dance? And they look like they're having a little get-together. You have two tornadoes dancing around, and then, okay, thanks, see you later. So these simulations, the fact that we're seeing this sort of messiness, this sort of chaotic stuff that you sort of see in Mother Nature is actually a good sign. It means our models are probably contain a lot of the necessary stuff that we need to get this right. But we don't have trees, we don't have houses, we don't have debris, we have rain in our tornado. I mean, I could sit, it's sort of like, everybody can always point at the most, the critical things in their own work, right? It's so easy to pick those out. But there are some things we need to work on. But on the other hand, there's enough that we're getting right that I feel like we've got this, we're in pretty good shape here. So this is the vorticity again. This is the streamlined vorticity current coming in. It's definitely more messy than it was. You can see all these individual vortices kind of comprising this mess. Here's our anticyclonic tornado we were looking at earlier, the one that starts right away. And if you look really closely, out of this mess of red, you will see a big tornado start to form. There it is. So, like I said, where's the trigger? Is there anything that we saw before that we could use to predict that it was going to happen? And that's where our research is right. I mean, that's one of the directions our research is going. At this point, we're just trying to understand this crazy simulation with all this amazing data, or several simulations. Here's a view looking along the SVC, and you can see that rotation beautifully. Here's this big mess of stuff, but it really is rotating. It's rotating horizontally, it's being tilted, and rotating vertically, and ours our tornado. Okay, so for the rest, about next 3 minutes or so, I wanted to intersperse, this is something that Hank Schima did. He did a little YouTube interview with me, which was a lot of fun, and he did a section of his presentation where he compared some of my model simulation work with his observational work, and I think this is wicked cool. So we'll start out with the tail cloud, or your ghost train type cloud that's streaming in from the right. And there it is in one of our simulations. That looks good. Looks like we got that pretty well. Here's our vorticity field. So here we're looking at, on the left, I'll pause it. This is a similar view as to before. Here's our big tornado, our cyclonic tornado. Here's an anticyclonic vortex, cyclonic, anticyclonic, duck, duck, goose. There's a whole bunch of stuff in there. We see evidence of little tiny vortices that aren't tornadoes in real storms as well. And this is the kind of thing that I'm always, when people talk to me about what should I be looking for if I go chasing, I'm saying, well, keep an eye on the forward flank and look for little vortices. I mean, again, I'm being selfish here, but I'm saying there's interesting things going on. And I'm not saying that that's super important, but it might be. Here's where Hank compares the sort of the turbulent growth of the cumulus turrets to a time lapse of his own. Wall cloud looks pretty good. Rotating wall cloud, and here's another version of the tail cloud that looks really good. Oh, it doesn't show up too well, but there's just a screaming tail cloud. A very barrel-like sort of laminar type mesocyclone at low levels. You see that as well in many cases in supercells. A laminar region that is overlaid by a turbulent sort of, the clouds start to really rise freely, turbulently, and finally we have multiple vortices in abundance, and this next actual video is from Wynnewood, I think. One of my favorite tornadoes recently, at least from a photogenic perspective. Lots of interesting things. There's some horizontal vortices and vortices being twisted around. Here's a view through the forward flank, or the rear flank, where you see the tornado is completely rain wrapped and it's obscured, and then it kind of peeks out for a little bit, and then it kind of gets obscured again. I don't know how he did it, but Hank found something that did exactly the same thing from the rear flank. He's in the rain a bit. You can see the tornado, looks pretty good, and then suddenly it's gone. It's been obscured by rain, and then it sort of reemerges later on. Anticyclonic funnel I talked about earlier, technically it might be a tornado, I haven't looked at it too closely yet. We see these in Mother Nature as well. There was a really photogenic one in Colorado a couple of years ago that was just absolutely beautiful. And this I had to do twice, I thought it looked so cool. Clematis clouds, real clematis clouds, fake clematis clouds, storm clematis, simulated clematis clouds, and then the real ones again. But I love that because it looks pretty good. You know, again, I have to look to Mother Nature because otherwise it's all just screwing around on the computer. You got to compare to the real world. Finally, this last sequence here, it looks kind of like a streamlined vorticity current. You've got clouds along the forward flank coming in and rotating, and here is the same thing that we see in our simulation. So over the next minute or so is kind of putting stuff side by side. I thought that was kind of cool. You blend in a stovepipe tornado to our simulation, looks pretty similar. It's a real nice way to sort of look at where the state of the art is right now. What's on the left is clearly fake, but what's